this is not ideal here. I had a lot of trouble getting this sequence right to be able to make it to walk. I still don't like the way it is. Probably need to make something different for that, but I don't know yet. Really haven't decided what I'm going to do, but as you can see, it walks. And it doesn't, not very robotic-like, which I don't know if that's a good thing or not. But it's pretty sloppy, but that's the beauty of it, I guess. There's also a crack on the floor that gets caught in sometimes. Oh, right here. So really it's all about the timing. So this board down here is to control the servos, and it's somewhat of a neural network servo controller. It's about 16 neurons. It's got 4 for each leg. When it receives input, there's an input for each leg. So when it receives input from this board, it basically pulses the leg and creates a walking gait for that one leg. So you can, as you can see, the timing between legs is crucial, and that's the part of the problem that I'm having, is getting this timing just right, because these here are individual micros that run independently, and then there's a third micro for the servos. And I have some sensor neurons I'm going to put on the legs here for light and for object. It can actually turn and reverse, but there's no servos, or there's no sensors hooked to the inputs. In fact, if I hold down a button, you'll be able to see it turn, and it does a pretty good job of it, actually. See, it's trying to turn now towards me. I have the input, one of the turn inputs, well, both turn inputs connected to a button on the board. And these white lights in here, what you're seeing is, so when it receives an input here, and it runs down the chain for the leg, it creates an output, just so you can, as a visual indicator, just so you can see like which legs are being activated when. I wanted to use it as outputs to go to other neurons, but if you have these inputs connect to other inputs that have other outputs going to them, they interfere with each other, so I disconnect them. But they're useful for you know, debugging or whatever. So what I'm going to do to this servo program is I'm going to add one more thing, where when there's inactivity for a certain period of time, the robot centers its servos and then relaxes to save battery power. I just tried it and failed miserably, but what I'm thinking happened is I was working on an older version of the code because it was totally broken, and I don't think adding that reversing or the relaxing thing broke the code. I think it might have been an old version of it or something. But I have a different idea, so what I'm going to do is I'm going to add just a separate input, a third input. Well, technically there's 6 inputs, so it'll be a 7th input, and that input will be, when that input is above a certain threshold, or if it triggers, it could be a neuron, what will happen is the robot will center its legs and relax. So that's a simpler solution to that. So see, right now it's continuously walking, and that's just because this circuit here is stimulating the leg neurons. So I kind of like the way it has this clumsy looking jerky kind of walking gait here. Yeah, I'm gonna measure the batteries in a minute. I had one hell of a time getting this working. So now if I had a a little circuit built here that had perfect timing for the legs, you would see it walk with absolute perfect timing, and it would look a lot more robotic, but it's because of this circuit here. So, but we're gonna have all these things working together as a whole, which will create a much more lifelike robot, hopefully. I'm also testing this power supply circuit here, DC to DC converter. It's meant for 5 volts out, but I'm modified it for a little higher than that. I need to get a different resistor value so that I can make it put out like 6 volts instead, for the servos only. So there, it's working now. If I go in and kill the chain, you'll see that it will die. Oh. It took a little longer than I thought. See, so what's going on is the neurons are still firing internally, and they're still working their way down the links and the chains and the, I guess I should call it the synapse, etc. So what you have is I have like I said, there are there are chains of 4 for each leg, and they're connected together internally inside the circuit. So this chip has 16 neurons in it, and then I have 4 neurons up here which are separate neurons. You can see all with their own micro here. Like I said, I have some light sensitive neurons that are going to go on the legs, and then some touch sensors that will go there. It's just this is just kind of a for fun thing. I got out of building robots for a while because they all always ended up being predictable. So the end goal was, well, I have another robot that I made a while back, and I gave up on it because I just couldn't decide what I wanted to do with it and how to make it realistic. And then I put it aside, and then I came up with this Neuron thing, and well, I figured the neurons would be good for the robots. Holy shit! Oh, it's gonna start walking on its own again. So that's the other thing, is the neurons ping each other, just like I've said in my other videos, and they do that to create some activity instead of just sitting here. And so that's what's happening, is they slowly kind of get bored, I guess you could say, and then they will start firing on their own, and it will start walking again on its own. I might remove that feature once I have sensors on it, because it will be motivated by sensors, or I might leave it on. I don't know yet, but let's see here. Hopefully it will starts to get a little twitchy, and then it kind of comes back to life, possibly. Huh? Needs a sound sensor so I can snap it back on. It's a bit of a mess as well. This is the wire I use to manually jolt him to life, and this is the ground wire for charging. So I have this battery pack on here, which is from laptop batteries. This thing was all just, what I had laying around, scrap. This frame for this robot I had built probably 15 years ago, and I actually have a video on YouTube of it. Walking. It was remote control at the time, and I yanked it off because it was boring. So I figured I would use it finally, and it's going to be permanent at one point. This thing's going to be built, permanent, and never touched again. And if I want to do something else, I'm going to build a whole new one with a whole new frame, something less rickety, I guess. Oh, and the batteries, there are 3 in parallel, and then another set of 3 in parallel, and they are in series. When I turn the robot on, they connect in series to this switch here. And then what I did was, when I turn it off, they connect themselves in parallel, Well, I shouldn't say they connect themselves. They get connected in parallel so that I can charge them all together in parallel. Come on, let's go. Start walking. You see the LEDs are starting a little green. Isn't the thing is they die. They leak. It seems like they leak too fast before they start. I've been screwing with the code so much, it's just kind of sick of trying to tweak it. So I may come up with a central pattern generator in a separate chip, like a 4-neuron one, so that it has perfect timing, so that it walks a little bit better. I don't know. I mean, this works, but and then I have inputs so that it can be modified. Or if it gets stimulated, it'll modify it. There it goes. Shit, it's walking fast now. See, so the pattern in here is it changes actually the more times it walks, it modifies itself a little bit. So the longer it walks, the I don't know, the different it walks. I guess you could say. Slow down. Kind of screwy. I did that for a reason, because I couldn't figure out how to set things and how to, I kind of like the dynamics of it and the craziness. So anyhow, once I'm done farting around with this, I'm going to go back to my wheeled robot and implement the same kind of control system. I'm going to put a bunch of individual neurons on it, just like the ones here. And I'm going to put a main micro, a 32-bitter. And go from there. But I learned some things from this. It should have started the other way around, but I guess it really doesn't matter. Also, if I ever make another one of these, what I'm going to do is, instead of doing this, I'm going to have a controller for each leg. A 32-bit micro with a 32-bit PWM, and then just the 4 internal neurons, and so that it can run at a faster speed and be much faster, much smoother. And that will give me a lot of extra room to do some stuck again. Do some I can make him walk, take slower steps, or nice smooth action. And individual, this micro has to kind of manage all the neurons inside the legs, and so it's got to go through some arrays, and it's kind of I had to set the clock speed kind of slow, because if I set it any faster, the PWM, which I'm using for the servos, would be too fast, which kind of really sucks actually. But it works for now, so cool. So maybe today I put the other shit on it. Oh, look at that. Speeding up again. I gotta check the batteries and see how well they're draining and make sure they don't fall past their limit. Wow, I really like how it's working now. It's strange. Maybe I will keep this control system on here. Well, I guess that's about it. I better turn her off and shut down the video.